In this series of videos, we're going to review Econ 3100 Section 90, Labor Economics, midterm exam number 2. And we'll first go through and review Section 1, which was Problem 1, the mandatory problem. That'll be a video in and of itself. In a second video, we'll review Section 2, Questions 1 and 2. And then in a third video, we'll review Section 3, Questions 3 and 4. So let's go ahead and start with Problem 1. In Problem 1, we had Kendall, an 18-year-old high school student, and we were creating here a human capital investment equation or scenario in which you needed to determine first Kendall's current wages, which you could do by looking at her current skill set and the labor demand and supply curves here that parameterize that skill set. So labor supply at negative 80 plus 30W and labor demand at 400 minus 25W. And that this would give you a current level of wage for her. You then are able to consider what her potential future wage is based upon this investment that she's preparing to make, and that's parameterized by the equations labor supply equals negative 5 plus 3W and labor demand equals 100 minus 0.5 or 1/2 W. And you're told here that W is an hourly wage. I think we can reasonably assume that an hourly wage would be multiplied by 40 hours a week times 52 weeks a year to think about an annual wage. And you're told that L is the number of workers in thousands. So we've said that Kendall's thinking about making a human capital investment. In this investment, she's apparently very impatient. She wants the investment to pay off within a 7-year period from the beginning of her investment experience, which 7-year period includes the expected 4-year education process. So you're being very impatient, of course, but she doesn't have a big investment expectation. She's only got a personal discount rate of 5%. You're told that you have identified that it's going to cost her $20,000 per year payable at the beginning of the year, and that while she's working, she's going to reduce her current income by $10,000 a year so that she can go to school full time. I then further indicate that expenses are to be accounted for at the beginning of each period and incomes are to be accounted for at the end of each period. So I've gone ahead first and identified her current income. I've gone through and looked at this in the usual manner. This is fairly simple to you now. And I've identified W star, or her wage, at 8.7273. You could have just said 8.73. It wasn't necessary here that you necessarily identified the equilibrium value for labor. Later on, that's going to make some sense to us. We'll need that. But we identify that as 181.812. And remember, that's thousands of workers per, so that would be 181,812 workers if we had to think about it that way. Well, similarly, I've gone ahead and identified her future wage the same way, and we figured that is $30 an hour, 85,000 workers, $30 an hour is 62,400 a year. So I took 30, multiplied it by 40, multiplied that by 52 weeks a year. Similarly, the $8.73 was $18,152.78. If you're a couple of pennies off from this, or even $1 off from this, this is not going to make much of a difference in the outcome of the equation, and I certainly wouldn't adjudicate it as though it was different. So now we have to figure out how to put this equation together. Remember that this is the basic human capital equation, which is really a present value equation. That is, present value is equal to the sum of beta t divided by 1 plus r to the t. And beta in this case is simply some cash flow or change in income, change in cash flow as a result of the investment experience. And r is the discount rate, 5%. T in the denominator is an exponent, so we're going to actually use that as a mathematical operator. But T in the numerator is simply a subscriber, doesn't really do anything. So since we know that we're accounting for expenses at the beginning of each period, and we've said $20,000 $8,000 per year payable at the beginning of each year. Well, the beginning, so the start of the experience, is now. We're not waiting for the year to be over. She's doing this up front now. So the denominator in this case for the first term is going to be 1.05 to the 0. We know that any value with an exponent of 0 is going to equal 1. And so we're putting here the negative $20,000, which is her expense for her education in that first year. In period number 1, so after the first year, we now have the beginning of the next year's tuition, expenses to pay. That's another $20,000. Plus, she's going to forego she was reducing her income to $10,000. She wasn't foregoing $10,000. I misspoke a moment ago. She's going to decrease her income to $10,000 a year. Well, if it's currently $18,152, she's going to forego $8,152 worth of income. And that's how this equation is built. So in the first period that we're looking at, which is period 0, we've got $20,000 of expense for education. We have that for another period, and another period. That gives us all 4 of the years of education expense we've got to account for. We're doing it up front, though, so it only took us to year 3 because we started in period 0 now. And then we have to account for her loss of income in those 4 years of education. We indicate that we're accounting for incomes at the end of each period. So we account for this each of the 4 years, starting with period 1, 8,152 as a negative, and you see it again, again, and again. And then we can think, okay, fine, she's at the end of her education experience, but she wanted this to pay off by the end of 7 years, including the 4 years of education, so she expects to only run this out to 7 years, which doesn't give us an awful lot of opportunity for this investment to pay off. And the change in her cash flow that she'll experience is the difference between the income she expects to make at the end of this experience and the income she makes now. We don't include the entire $62,400 in the numerator in the benefit part of this because she's already making $18,152 without the investment. So the investment's only going to benefit her the difference between those two values. And that would be $44,247 and some change. So that's question number 1. And you need to give me the form of the equation. I've told you that you didn't have to solve it here. You obviously had to solve it a few steps later, or the next step perhaps. But here, this is the form of the equation. And I could look at this equation, and I could go ahead with a calculator, and I could calculate this to some value, just as I've told you must be able to do here. So the next part, we're saying, what recommendation would you offer her? Be sure to give a complete response, including the specific time discounted net cost or benefit you expect she'll encounter. Well, in this case, because of her impatience at the end of 7 years, if we've gone ahead and calculated each of these terms correctly with your calculator, you're going to see that it's negative $20,000 and then negative $26,811 and so on for each of these terms that we might consider here, and that's going to give us a sum of negative $4,237.32. So at the end of 7 years, after her 7th year following the beginning of the investment experience, she is in the red, $4,237.32. Remember that our decision rule is based upon if present value is greater than, equal to, or less than 0. When it's greater than 0, we like it. Less than 0, we dislike it. Equal to 0, we're indifferent. Here, clearly we're less than 0, so we have to recommend to Kendall that based upon the parameters that she's given to us, that she does not participate in the education experience. I went ahead and went a little further here. In this case, Kendall's my granddaughter, so I can do this. And so I've said, that's a little impatient. Think about this. If she simply went into the next period, which would give her another $44,247 discounted by 1.05 to the 8th, that's going to then take her into positive territory. Well, 7 years after she's 18 is only age 25. Add 1 to that, she's only age 26 at that point, which means that she's got from age 26 all the way through, age 60, 65? 70 in order for this to pay off. In this case, the education experience would have been a safe bet, but not based upon how she asked us to adjudicate this. So the answer for B is we'd have to recommend that she not do this. We go on to then have you look at this from a elasticity standpoint. And you have to remember that the equation for elasticity is seen through this kind of funky N, if you will, and it is percent change in labor given some percent change in wage. That's your basic elasticity equation. We can either use a simple form of that or we can use a midpoint formula for that, but that's the basic equation. And so I've said, okay, what happens if Kendall's wage changes by $2, either at her current skill level or at her future skill level? Well, remember we calculated her wage at her current skill level. It was $8.73, you might say, and labor was $181.812. At her future level, we then created a W star or W1 of 30 and a L1 or L star of 85. If we go back to the low skill set, the current skill set, a $2 change in wage goes from $8.73 down to up to $10.73. And if we take and plug that $10.73 into the labor demand equation, not labor supply, because this is the elasticity of labor demand, then that tells us that it's going to decrease the amount of labor demanded to 131.825. The most common mistake I saw here was appeared to me that you took the new wage and put it into the labor supply equation, which caused us to see an increase in the labor demanded, which doesn't make a lot of intuitive sense. And I was a little concerned that some of you did that without that bell going off in your head that, wait a minute, increase in wage shouldn't increase demand, should decrease demand. At any rate, so we then see over on the other side that going from $30 to $32 decreased the labor demand from L1 of 85 to L2 of 84. So I just went ahead and motivated these equations in the normal way. I won't do both of them for you here. I'll just use the future because if you think about this as the percent change equation, and percent change with respect to, let's say, labor is going to be L2 minus L1 divided by L1. This is really more generally P2 minus P1 divided by P1. Or when it's in the denominator, it's going to be W2 minus W1 divided by W1. And that gives us the percent change that we're looking for here, so we can give both the denominator and numerator of these equations. So 84 minus 85 divided by 85. All of that divided by 32 minus 30 divided by 30. That gives us negative 1 divided by 85 divided by 2 divided by 30. I like to rearrange those. I like to take the denominator, invert it, and multiply instead of divide. I don't like these complex fractions. Some of you are very comfortable with them. I prefer not to deal with them. So I do that, and I end up with an elasticity of negative 0.1765, which is inelastic for the future wage skill set, which is a higher order skill set, and we would expect that to be inelastic, or we would think it might be, because it's not as easily substitutable in the marketplace. Using a very similar structure, I identified the current skill level elasticity of demand when there was a $2 change in wage, and it gave us a demand elasticity of negative 1.1997 or 1.2, which was elastic. And that's the answer to C. I then said, finally, Kendall's becoming increasingly concerned about the effects of refugee migration on domestic labor markets, offer an explanation with respect to how this form of labor migration may affect her given her current skill level and her expected potential skill level after completing an education. Well, there's a lot you could say here. And if you're reading perhaps some of my handwriting, if you can read some of my handwriting, you'll see that I've really talked here about how refugee migration not unlike immigrant migration, will mostly affect the unskilled labor force, but with minimal effect at all, based upon some of the rigorous testing that we've seen. If you thought about the Canvas discussion on immigration and some of the comments that I made in the modules, you know that we actually have observations that tell us that we really don't see much degradation. In the low skilled wages, but we also don't see that they rise much. In fact, maybe this kind of immigration dampens potential increases, except for if one is in that low skill set and one speaks the domestic language well, it raises the relative skill set of that person, which might possibly increase their opportunities and increase their incomes. For the highly skilled in a marketplace, refugee migration or regular immigration tends to be either neutral or positive. I say either neutral or positive because refugee migration, as I pointed out in one of the announcements I sent out via Canvas after you'd finished the Canvas discussion, where I gave you several paragraphs of information about refugee migration versus immigration. There's really two different things when we think about it technically. Refugees coming into a polity really don't provide much growth in GDP, growth in incomes. They provide some utility satisfiers in that we are taking people out of hellish conditions, perhaps, and bringing them into what would hopefully be a better life for them. Whereas the immigrant population is, by and large, going to provide a positive effect in wages at the upper end of the pay scale, at the upper end of the skills set. So that's how you deal with problem 1, section 1.